All right, good day and welcome back to Everything Mathematics. And today we're going to continue our series, or not rather continue, we're going to start a new series. And the focus for today, we're going to be doing a little of algebra, right? A little algebra. But in today's algebra, I want to focus on a basic concept that I think could lead to understanding a lot of the complex stuff. So let's call this some basic algebra. And today we're specifically going to be looking at addition and subtraction of algebraic terms. And to understand this, I want us to start with a common understanding, with a common example that we all know, and then see how math sometimes puts the algebra attached to it. So a simple reference, as I was teaching my nephew a few weeks ago, is this, and I think this is something we could all relate to. If somebody, for instance, has 4 lines, I think this is something that's very relatable. Somebody has 4 lines and somebody else has 3 lines. I think we all could see lines as something that we all know, that citrus, that wrong little thing. So if I have 4 lines and somebody else has 4 lines, and we want to add our lines together, I think it's pretty evident that we could easily see that 4 lines plus 3 lines will equal 7 lines. And this is real life stuff. This is how we do it in real life. If I have 4 lines, you have 3 lines, we want to put our lines together, we add the 4 and the 3 and the lines remains the same. And that's a fact, that's very straightforward. But let's look a little how maths deals with it now. When we do maths, yeah, sometimes you will see the whole thing, lines, pencils, pen, whatever, we add in. But maths now, sometimes instead of using line, they use what we call an unknown. So instead of line, let's say they might use the letter A. So 4A plus 3A. And sometimes when we see this, once we see it like this, headache starts for some of us. It's like, okay, what is A? What do I do with A? But one thing you need to understand about A is this. Whatever A is, we don't know. For now, let's leave it like that. We don't know. But there's one thing we could appreciate or accept about the letter A. That whenever you see A is common to A. As a result, it is possible to add them together even if you don't know what is A. So what is it to take away from here is that so long as the terms have the same unknown, let's put it like that, it is possible to compute. It is possible to add them. As a result, 4A plus 3A would give us 7A. And this also makes perfect sense. In spite we don't know, in spite the fact that we don't know what is A. The same is true when it comes to subtraction. So for example, in real life, if somebody has 10 pens, let's say somebody have a lot of pens, so somebody has 10 pens, and you want to take that away from somebody who has 4 pens, or not even take away, let's say you gave away 4 pens. So you have 10 pens, you gave away 4 pens, and it's very logical to see here that 4 pens minus 10 pens will leave you with 6 pens. That's very logical to see. But similarly, sometimes when we throw in the algebra, then the headache starts. So now if I have 10b minus 4b, again, the concept is the same. All we need to understand is that although we don't know what is b, the fact is that b is the same as b. As a result, we could compute the numbers. So the answer here will be now 6b. And that's basically what we need to take away from this. It's as simple as that. Of course, sometimes you have a real life scenario, and this is something you have to realize for yourself too. Supposing we have five, sorry, I got to erase a so because I'm using the other one. So supposing somebody has 5 what? Let me put something else. Oh wow, this is good. Right. So supposing somebody have what? Five. Oh, let me stick to the lines. 5 lines. Good. And somebody else now has 4 pens. Let's be real. Is there a way to put lines and pens together? I mean, let's think about it. If we go to add this, what can we get? Can lines and pen come together? Can we get line pens? Can we get pen lines? Can we get pen and line? I don't know. So in a case like this, we need to understand that even in real life, if somebody has to make a count, let's say somebody counting or somebody's grouping, at the ending of the day, our result here will be the same thing that we're trying to add. So I have 5 lines, I'm trying to join with somebody who has 4 pens. My answer will still be, guess what? 5 lines, 5 lines. And when we speak, we will say and, I wrote that wrong. and, as we speak, and 4 pence. That's the best we could do here. And 4 pence. We cannot fuse these two. Even if I had mangoes instead of pence, you might think, oh, because it's an object and a fruit or whatever. Even if I had mangoes here, you cannot fuse mangoes and limes because they are two complete entities, two completely different entities. And the same is true when we do maths. For example, if I have, let me go back to our limes. We represented lime just now as A. And then we have our 4 pence. We represented pence as B. Even when we do maths, believe me, I have a lot of students who, when they try to solve this, they believe the answer is 9AB. They just put everything together. But this is wrong. This is not true. That cannot work. Why? Because you simply cannot put two things together that have common, that are different in any way you want to look at it. So at the ending of the day, our answer here will be the same thing we started with, 5A plus 4B. Simply because A and B have nothing in common. A and B have nothing in common. As a result, our answer will be the same difference. It cannot come together as one. So you have to bear that in mind. And the last scenario, and I'll just do this one before we just do a few examples so that we understand how it works. Our last scenario, of course, is sometimes we have more than one, and I will stick strictly to the algebra here. So sometimes we have things like this. We might have 4A plus 3A plus 5B. And what we need to take from this is that whatever is common, we could compute. What is not common, we cannot do anything with it besides just leave it as it is. So here we could appreciate that the A's could add. The A's could add. So if I add my A's here, I should be able to get 7A. But then when I go back to my B, I would notice that I will still have plus 5B. And believe it or not, this is the answer. That is it. That's the answer. Because what could compute, we could compute, we compute. What we cannot compute, we leave it like that. A simple reference I like to use a lot when doing this with students is that of money, currency, or even units of length and so on. But I think money is the easiest way to pick it up. Imagine somebody have two different currencies with them. Like in Grenada, we use EC. So imagine somebody have 10 EC, yes, EC. They might have 20 EC, yes, 20 EC. And then they also happen to have with them 100 US dollar. At the ending of the day, when that person put all their money together, do you think it will be right to say that that person has $130? Well, yeah, they do have $130, but is it EC or is it US? And I'm pretty sure nobody could answer that. Good. So yes, when the currency is different, even us, we need to understand that, okay, yes, they do have all this money. They do have a sum of 130, but that's not the what, that's not the real value that they have. What they actually have with them is 30 EC dollars, and then you could say they have 100 US dollars. And this, anybody would understand this because you just cannot mix two things that are not of the same what? The same background, the same backdrop, the same, whatever you want to look at it. However it makes sense to you. We need to understand that. And that is the fundamental principle that the unknowns in algebra plays when we do maths. If you want to add two things together, then they must be common. So I know some students sometimes they hold their head as to why the A is there, why A, why not B, why not C, why X, what is X, why Y? What we need to get that is that it could be anything. It's sad to say that yes, in truth, sometimes most times they use X or Y or whatever. But X and Y have their purpose, they have their reason. So that's why they don't run away from those. And especially when they're dealing with coordinate geometry and so on, yes, X and Y is significant. Even quadratic equation is very significant. But we need to understand when it comes to an unknown, it could be anything. And the gist here is that you could only compute things that are common. Just as though we could add money of the same currency, only so in maths we could add letters that are the same. You could add A with any A. You could add B with any B. You could add limes with any amount of limes. You could add pens with any amount of pens. It don't matter if it's ballpoint pen, if it's gelling pen, if it's whatever pen. Once it's a pen, you could add a total sum of pen. And the same thing happens when we do algebra. So let's see if we could easily do some questions here and see if we could solidify the concept. So here we have, let me just do 3 for now. And notice the instruction here, we say to simplify. And simplify simply means that you're not going to end up with a solution. You're not going to end up with an answer, but you're going to end up with an expression that is simpler than what you're starting. So number 1, for instance, let me say we have 5a minus 6b plus 3a minus 10b. Oh yes, and of course you have the other elements of algebra where all these things could be played with. Then let's say for question 2, we have 12, let's say p minus y plus 3p plus 10y. And last but not least, let's say we have here what, 8q minus 12q plus, let's say 10b. And of course, here you could pause the video and solve, but I will just go straight into the solutions of these questions and them. So if I have 5a, again, notice we could only add the things that are common. So here we could see, or we should see, that 5a and 3a is what we're really looking for to pair it. And then we have to see that 6b and 10b is what we're looking for pairing. So notice that this 5, and this is the other part where algebra could show us off, we need to understand that this 5 here is positive. So in essence, we are adding 5a with 8a. And once we do that, we should get a result here of, let me use a different color here. We will get a result here of 8a. Let's look at the b now. The b could be a little tricky if we don't know our signs. Here we have a minus 6b and a minus 10b. So I know the result will be negative already because the rule says if we add in two negative numbers, we add the numbers and we keep the sign. So this will give us minus 16b. And that is as far as we could go. Anything beyond this is if we have substitution. And we're going to be doing substitution later in this week or maybe next week. So yes, please take note of that. Let's look at the second example here now. For the second example, let's see if we have anything in common. Right, so look at, we have a 12p here and we have a p here. Observe that this 12p is positive and this 3p is positive. So technically we are having 12 plus 3 and that will give us 15p. And as for the y, let's see what is happening with the y. This y is negative, but this y is positive. So the rule states, take away, oh, and notice that there is a 1 here. In case you don't know, there's a 1 that is understood here. So the rule states that we take away the smaller from the bigger, but we keep the sign of the bigger number. So if we take away 1 from 10, we would end up with 9. Which sign do we keep? We keep the positive sign because the 10 is bigger than 1, and that will be y. So that's our answer, 15p plus 9y. And last one, number 3, we have what? 8q, we have a q here, right? So we could see q's present. So we have a q here and we have a q here. So what do? We could compute these two. Notice this q is negative, this 12 here is negative, and this 8 here is positive. So what it will say, if the signs are different, take away the small one from the bigger one, but you keep the sign of the bigger one. So this will be minus 4q. And then the 10, since there is nothing else to add with that 10 there, that will just be the 10 as it is, plus 10b. Of course, some persons, sometimes they don't like, well, for me, let me talk about me. I don't like to see the negative in front. So I will might sometimes shift this around. I will say the answer is 10b minus 4q. And that's the same thing. I just switched the positions. I did not change the value. I did not change the question. It's the same question. So yes, this is how we go about tackling basic algebraic expression. How we add and subtract is really straightforward. Tomorrow, God willing, we're going to look at what we do when we have to multiply and or divide algebraic expressions. So until then, you take care. All the best.